Hey guys, Mr. Bowman here. Today's learning objective is in blue. We are learning to determine the nature of stationary points for a given function, and emphasis added, we are not going to be using the second derivative method. So how can we do that without the second derivative? So the first thing we're looking to focus on is we are having a big emphasis on stationary points. We need to understand their nature. So at a stationary point, we are always going to have a gradient that will be equal to 0. And another way to think of that, y dash or f dash x or dy dx, at that point, y dash equal to 0. The next one, there are 3 types of stationary points. We do need to be aware of all 3 of them because mathematically they are different. So the first one, when you have a negative parabola, maybe a cubic, the turning point at the top before it goes back down again, that is referred to as a maximum. Conversely, when we have a positive one, these are referred to as minimum. So I'm sure this is a recap for most of us. And finally, this last one is a bit new. We'll draw a bigger, better diagram actually. So for cubics, there's a point there where technically it has a gradient of 0 or horizontal line. Those are called points of inflection. Each of these are slightly different, but mathematically we can figure out which one is which based on the gradients around the point itself. Okay, so let's get into our first example. So I'm going to change pen colors. Let's get into the yellow one because we're doing the yellow question. Okay, so our first step, we want to differentiate to find our gradient function. So we're going to get times a by n, so the constant or the coefficient up front by the power. That's going to become negative 1 times 2, which is negative 2 over 10, times x to the power of 1, because 2 minus 1 is 1, but we're going to ignore that, and we can ignore the constant as 10. So at this point here, we need to remember, at a stationary point, that's what we're trying to find, we know the gradient is going to be 0. So we're going to substitute that value in. So 0 is going to be equal to negative 1 over 5 times x. And what I've done there is I've just simplified that fraction as well. I'm going to then mathematically solve this. That's times negative 1/5. Move it over the side as division. That's going to be 0. So x is equal to 0. So we know the x value for our turning point is going to be at point 0. We then need to figure out, well, what's the y value? We'll find the coordinate itself. So we'll do that over here. So we're going to substitute in the x we just calculated. Y is equal to 1/10 of x times 0 squared plus 10. So all of that becomes 0, leaving our y value as 10. And that gives us the coordinate of our stationary point. It will be 0, 10. The next step, we just need to recap or figure out, is it a maximum, a minimum, or a point of inflection? So let's grab our table. So for this here, we do need to draw a table, and we're comparing the x value with the gradient at the particular point. And we're always going to need 3 columns. The middle column is going to be the point where the gradient, or the stationary point, the x value of that. We're then going to go -1 and +1. So obviously if the middle one was 2, it would be 1 and 3 either side of it. All right, so we've done that. Next step is let's find the gradient in each of these points, and that'll give us some information that we can use. So we're dealing with negative 1 first, so we're going to go negative 1/5 times 1. Well, that's going to be positive 1/5. So what I'm doing is I'm substituting the x value into that part there. We're then going to do the same with 0. Well, that's going to become 0, and we already know that because we've figured out that's the turning point itself. And at 1, that will be negative 1/5. So this tells us a lot of information. And the key thing is, at 1, the graph appears to be increasing because it has a positive gradient. At 0, it's then flat or level. Just get rid of that. And then once you get to 1, it started going down again. And what you can kind of see, those three lines, that forms a bit of a U shape, suggesting, or a backwards U or an N, that suggests we're dealing with a maximum as opposed to a minimum or a point of inflection. So let's wrap up. So we found the coordinate, that's 0, 10, and we also found out at that point we are dealing with a maximum. So hopefully you found the first example useful. So that was our maximum, so we've done that. The next two examples, well, they're going to relate to the minimum and the point of intersection, or point of inflection as well. So let's switch to the green pen. Let's do the green example now. So this is a cubic. That's the first thing to note. The other two are parabolas, but we're dealing with a cubic here. First step, we can get straight into differentiation. Power times number in front, well, that's going to become 9. We're going to reduce the power by 1, and minus 4, see you later, that's a constant, that becomes 0. We're then going to substitute in, so just a reminder, at the point we're interested in, we know the gradient, or y dash, will be equal to 0. So 0 is equal to 9x squared. That becomes 0 over 9, which is still 0. And then the square root of 0, also 0, which will leave us with x equals 0. So that tells us the x value of the turning point. Let's put that back into the original equation to find out the y value. So y is going to be equal to 3 times 0 cubed minus 4, and that's going to become negative 4. So we've got our coordinate 0, negative 4. We now want to set up our table. We want to figure out the direction of the parabolas on either side. So the direction of the cubic on either side of that turning point. So let's have a look at that. So we'll set up x over here. We're comparing x with y dash. And we're dealing with 0, so we need to go negative 1, 0, and positive 1. And we need to see what's happening either side. So we know 0, that has a gradient of 0, because we substituted that in above. We now need to figure out what's happening at negative 1, what's happening at 1. So we're going to substitute negative 1 into our gradient function, which I've just circled above. So 9 times negative 1 squared. So negative 1 squared is positive 1. 1 times 9 is going to be 9. So that's got a positive gradient. That's increasing as it gets to the stationary point. We're then going to put in positive 1. So positive 1 squared is 1. 1 times 9 is also 9. And again, so that's saying it gets to the turning point and it's going to continue shooting on in a positive direction. So if you map that out, so it looks like we start off negative, we level off, and then we start off positive again. And all of a sudden we can see on either side of the turning point, it's going in the same direction. And that there is the giveaway. If they're both positive or both negative, that tells us it's a point of inflection. So that's our last one. So therefore, 0, negative 4, that's the coordinate of the stationary point we calculated. And that's going to be a point of inflection. So well done if you've got that and you're developing your understanding in your head. So that's the first example. We've done the second example. What I'm going to do is I'm going to pause the video. I'm going to get rid of the yellow one. So if you haven't read it down, you please need to. And then we're going to finish off our video with the pink question. Okay, all of that is cleared. Some of us would have figured out we just did a point of inflection. And as I said earlier, we're going to do one of each, which means this is going to... So we're going to start off with our equation. We're going to differentiate. Oh, no, sorry, apologies. We're going to simplify it to make it easier to differentiate. So first step, let's get the squared. Let's make that a double bracket. And we're then going to subtract 2 at the end. We're then going to expand our double bracket. So that's going to be 1/4 of x squared minus 4x plus 4. And then we're going to subtract 2. We're going to expand that. That's going to be 1/4 of x squared. We're going to minus x. We're then going to add 1. And again, minus 2. And finally, we're going to simplify that. So that's going to be 1/4 of x squared minus x minus 1. That looks a bit easier. We can now go through and differentiate that. So y dash, that's going to be equal to 1/4 times 2, which is 2/4, which is going to become 1/2. So 1/2 of x. And then negative x, well, that's going to differentiate to -1. And we're going to ignore the -1 at the end because that is a constant. So that gives us our gradient function. We know at our stationary point that the gradient, or y dash, will be equal to 0. So let's substitute that back in. So 0 is going to be equal to 1/2 of x minus 1. Let's solve. That's going to become x divided by 2. That's the same as 1/2 of x. And we're moving the -1 to the other side. And that's going to become 2, because 2 times 1 gets us to the 2. So that's the x value. Let's find the corresponding y value. So let's put that x value back into the original equation. So y is equal to 2 minus 2 squared, and then minus 2. So 2 minus 2 is 0. 0 squared is 0. 0 times -4, still 0. That's going to become -2. So that means our turning point is at 2, -2. We're going to set up our table like we did in our previous ones. So we're trying to compare x with the equivalent gradient. And we need 3 columns. The middle value in our table, well, that's going to be the x value, which in our case was 2. And we want to figure out, well, what's happening at 1, what's happening at 3. So we already know the gradient at 2 is 0, so we figured that out. Let's put 1 and 3 back into our gradient function to find the gradient at those points. So the first one, x is 1. So 1/2 times 1 is going to get us to 1/2, minus 1 is going to get us to -1/2. And let's repeat that for 3. So 1/2 times 3 is 1.5. 1.5 minus 1 is +1/2. And what that tells us about the nature of this turning point is it starts off negative, then it's flat, and then it goes up. And if you draw that as a parabola, there'll be a positive parabola with a minimum. And that reveals the last part of this video. So therefore, our coordinate is 2, -2. And this is going to be a minimum. So hopefully you found this video useful. We are learning to determine the nature of the stationary points of given equations, but we are not using the second derivative method. If you are keen to learn about that method, do have a look at the next video in the series. Best of luck. Let's get into heaps of questions.